Rising out of the flat desert sands in Edwards, California, is a giant metal structure standing 100 feet tall and almost 100 feet wide. It's made of industrial-strength steel that could withstand the harshest winds and rain. This monolith of the desert, located at NASA's Dryden Flight Research Center, has been an unsung hero in the life of the Space Shuttle program for the last 34 years. This steel giant is called the Mate-Demate device, or simply the MDD.
6 inches. We move 3 inches forward and 3 inches aft, and that's all the adjustments you have to set it on top of the 747. You can't move it any more than that.
You gotta remember that thing was built to lift 330,000 pounds. See a shuttle up close, you watch it take off on top of that 747 when it leaves here, and it's just amazing. You know you had something to do with it.
After the shuttle makes its grand re-entry, landing safely while the world looks on, and after the media has shut off their cameras and gone home, a vital, albeit less glamorous event is just beginning. The processing and mating of the orbiter in the MDD. After landings at Edwards Air Force Base, the MDD is used to hoist and attach the shuttle orbiter onto the Shuttle Carrier Aircraft so that it can be flown back to NASA's Kennedy Space Center in Florida. While simple in concept, the execution of this task is anything but. Considering the average landing weight of the shuttle is roughly 230,000 pounds and holds research and payloads acquired in outer space, precious cargo indeed. In addition to mating the orbiter to the Shuttle Carrier Aircraft, a modified Boeing 747, the MDD is utilized to process the shuttle, a week-long procedure that includes taking up the landing gear, attaching the tail cone, and literally battening down the hatches.
They have what they call escape operation, and that's when they do the actual defueling. And the people that are doing the defueling, they have to be in a full suit. It's air-contained, self-contained, everything has its own air and everything. It looks like the spacewalkers.
During the week of processing, the orbiter is lifted about 10 feet off the ground, while crews work around the clock.
That's the basic idea, is to put the shuttle on top of the 747. That whole process involves a week of processing to safe the vehicle to put it on the 747.
Just before landing at Edwards, Kennedy Space Center deploys about 120 people to Dryden to process the orbiter. Together with the Dryden team, this highly specialized team of engineers, pilots, and ground crew work in unison under harsh conditions, performing precision, high-risk tasks with a fragile 100-ton spacecraft.
If you don't do your job and do it right, there's always something that could happen that could lead to somebody getting hurt, harming in the shuttle. So you have to make sure your job is done and done right, and with all the expertise known and have. So, and that really what keeps you going is the pride in doing that.
Over the years, ground crews were able to perfect the art of mating and processing the orbiter, but never without risk and hardship. To fully appreciate the complexity and scale of this undertaking, it is helpful to understand how the MDD came to be and how it has served as an essential component in the success of the STS program at large. As the sun was setting on the Apollo space program in the early 70s, a new program, the Space Transportation System Space Shuttle, was dawning. One defining distinction between the two programs was that the Space Shuttle was a reusable spacecraft, unlike its predecessor. The shuttle, or orbiter, was to be lofted into low Earth orbit with the energy of 2 solid rockets and the orbiter's 3 engines fueled by an enormous external tank filled with liquid oxygen and liquid hydrogen. Upon its return from space missions, the orbiter would re-enter the Earth's atmosphere, flying without power, like a glider, and land on a long paved runway, like traditional aircraft. These methods of launch and re-entry proved to be very effective. With an extremely short wingspan and without the expendable external fuel tank used for liftoff, however, the orbiter lacked the ability to take off and fly like a conventionally powered aircraft in the Earth's atmosphere. From the start of the program, engineers recognized that the orbiters might not be able to return to their launch site at the Kennedy Space Center in Florida because of an engine malfunction after liftoff or because of unfavorable weather conditions.
Shuttle can't land in the rain, no. Once it breaks through the atmosphere, it starts cooling off, and there's enough space between the tile that any water penetrating actually hydraulically pushes the tile off of the shuttle. The water doesn't have any place to go, so the tiles are just glued on. That's why landing at Kennedy, always concerned because, you know, how much rain it gets there. And we're usually pretty dry here.
In this event, a landing elsewhere would necessitate bringing the shuttle back to Florida, which meant the need for a structure capable of lifting the orbiter off the ground and placing it on the back of the 747 Shuttle Carrier Aircraft. Using cranes to lift and attach an orbiter was deemed a far too delicate balancing act to sustain over the course of the shuttle program. It soon became clear that there was a need to build a permanent and reliable structure to achieve this task. Hence, the idea of the Mate-Demate device was born, and plans to fabricate and construct the first MDD were put into action. The Kennedy Space Center awarded a $1.2 million plus contract to the George A. Fuller Company, a division of the Northrop Corporation, to design and build the first Mate-Demate device. Soon after, the MDD at Kennedy Space Center was constructed in 1976. In the early stages of the shuttle program, it was especially important to build an MDD at Dryden first. Assembled in nearby Palmdale, California, the first three orbiters, Enterprise, Columbia, and Challenger, were actually trucked to Dryden. Once there, the MDD would be utilized for the first time in the historic and groundbreaking Approach and Landing Test Program in 1977. The Approach and Landing Test Program, or ALT, was an essential component in the development of the Space Shuttle program. Used to validate the flying characteristics of the orbiter upon re-entry and landing and test its systems in flight. The ALT program made use of the MDD for the first time to load and unload Enterprise onto the Boeing 747 in a series of high-risk test flights in 1977. In 1982, NASA arranged to have a permanent Mate-Demate device erected in Palmdale. The Orbiter Loading Facility, or OLF, was originally built for use by the Air Force at Vandenberg Air Force Base, where it planned to launch a shuttle for its own missions. When the Air Force canceled the plans for a dedicated orbiter and launch facility on the West Coast, the OLF was relocated to Palmdale.
Several years ago, they were doing refurbishment of the shuttles in Palmdale at the Boeing facility, and the orbiter would fly in on the 747, and they would fly into Palmdale, and we would offload it using the OLF, and then we would transfer the shuttle over to the Boeing folks, and they would do the shuttle modifications, and then, you know, maybe a year later, we'd pick the shuttle up and reverse the process, put it back on the 747, and fly it back to Florida.
The shuttle orbits the Earth at Mach 25 and makes its landing at over 200 miles per hour. But when the orbiter finally comes to a halt on the ground, the massive spacecraft is not easy to maneuver. After landing, the orbiter is towed about 2 miles to the MDD, a process that takes over an hour. Once situated in the MDD, the orbiter is lifted off the ground and held there for days while crews work under and over the orbiter, preparing it for its return flight. Because it is not hermetically sealed, the cargo bay is kept at a positive pressure, and the electronics in the vehicle are kept operational. This ensures that the equipment and any experiments on and in the orbiter are kept cool throughout its stay in the MDD.
Anything that's in the payload bay stays there because on the ground, the payload bay doors aren't capable of opening themselves. They have a special apparatus back at the Cape to hook into the doors to open it. The doors don't weigh anything in space, so they're driven with very small motors.
The MDD is an open truss structure. standing about 100 feet tall with platforms every 20 feet. A horizontal unit cantilevers 70 feet out from the main tower units, guiding and controlling the sling-back hoist mechanism that attaches the orbiters to raise and lower them. 3 large hoists are used to raise and lower the lift beams. 2 of the hoists are connected to the aft portion of the lift beam, and 1 hoist is attached to the beam's forward section. The 3 hoists operate simultaneously, and they can lift up to 120 tons each. There are 6 stationary platform levels, 2 movable access service platforms, 1 for each side of the orbiter, and other smaller movable platforms.
The old MDD was gray and red. Now if you look down there, it's all gray.
In 2004, Dryden took on the enormous endeavor of removing the lead-based paint that covered the entire MDD. As part of a 5-month process, contractors blasted the paint off the MDD.
The job was huge. There was so much scaffolding and tinting. Once you get a hole in the tent, you had to stop operations. No more blasting until it was repaired, because there was some kind of positive ventilation inside the tent that kept the dust down instead of coming out. We were having, 4, 5, 6 days of 30-mile-per-hour winds constant.
By adding an ingredient to the blasting material called blastox, over 200,000 pounds of waste material was spared from being sent to a waste management site. Instead, the waste compound was sent to a Portland cement plant where it was burned in a kiln.
It's a zinc finish, self-healing, so if it gets a scratch, it somehow corrodes and turns back into a zinc. It's an amazing stuff.
Don't have much to do with launch, but we know we got it back there safe from the last time, so always a sense of pride in everything.
Despite the intermittent landing schedule at Dryden, the support crew operating the MDD had an astonishing record of preparedness.
I like to think of myself as a good American for doing that. All my guys down there feel the same way, I'm sure.
You need to step back at times and realize, wow, this is what I'm doing. It's just a small group of folks that do it.
Throughout its history, the MDD and its faithful crew had a 100% mission success rate over its 34 years of service to the shuttle program.
When I look back someday, I know I'll think of these times and realize just how fortunate I was to have worked on the program. And it's just kind of nice to know that that you were part of something big. So that's about it.